So in my last video, I've explained what are binary numbers. I also said that we can do some basic arithmetic operations with them. So in this video, I'm going to be explaining what is binary addition and binary subtraction. Well, when we take a number, for example, like 156, and we want to add it to a number, for example, like a 37 in base 10, then we add them, digit by digit, which means we do 7 plus 6, which is 13, but we cannot write 13, so we write a 3 and carry the 1. Then we just add 5 plus 3, which is 8, but we have the 1 that we carried, which is 9. Yeah, and then we just do because we cannot add nothing here since this is basically a 0. So we get 193 in base 10. So how do we do this in binary numbers? Well, actually, we do it the same. I'm going to write the same numbers as we did here, but in binary, which is like this. Base 2 and in base 2. And then we basically add them just like we did over here, but since we can only represent two numbers, which is 0 and 1, we can, I'll get to that later. Okay, so we do 1 plus 0, which is 1, obviously. Then we do 0 plus 0, which is 0. Then 1 plus 1, yeah, that's 2, but we cannot write 2, so we carry the 1 bit. And then we basically just write 0 since, and then we add this carry bit to this bit, and then we get a 2 as well, since this is 1 and 1, but we cannot write 2, so we write 0 again. Then we carried one more, then we get this situation, which is basically 3 ones above each other, which means, that's 3. But when we cannot write 3 as well, so we just write the 1, because 3 is 1 and 1, so we just write this one, and then we add this one over here, which is 1 as well, and then we have 0 plus 0, which is 0, and 1 plus 0, which is 1. So it's basically simple like that. So this is the basics of binary addition. Well, when we get to subtraction, I have to first tell you that the way I'm going to be showing it isn't the most efficient and probably isn't used anywhere, because there are way better alternatives to subtracting numbers, such as two's complementing, but I'm going to be explaining that in a later video. So in this video I'm going to be explaining this janky method, which doesn't work very well and is very slow. Okay, so so let's first subtract some numbers in base 10, and then we can go to base 2. Okay, so when we do 178, for example, in base 10 minus 95, in base 10 it is, we subtracted like we do with addition, digit by digit. We take 5 minus 8, which is 3, and then we do not do 9 minus 7, but we do actually 7 minus 9, but we do 17. So we borrow a 1 over here, which is 17 minus 9, which is 8, and then we take this one and put it over here and subtract 1 minus 1, which is 0. And that's basically the subtraction in base 10, nothing new, I assume. So now let's do it in binary with the same numbers that we have over here. So let me just write it out. In base 2, and 2, and this is 95, and this is 178. I will do minus, and yeah, then we do this method. Okay, so since we cannot subtract 0, like 1 from 0, so we would get a negative number. We basically write 2 over here, and then we subtract 1 minus 2, which is 1. But then we get to this situation, which basically tells us to shift the 2 over here, since we get the 2 over here when we add these two. And then we do 2 minus 1, which is basically, yeah, 1 again. And then we come over here, which we have 1 minus 1, which is 0. But since we have this situation, we do this thing again, and then we get the 2 over here as well. And then we just subtract these two from each other and get it like this. Yeah, the same principle that happened here is happening here. So yeah, we get this 2 over here, and yeah, that is going to give us 1. Yes, and then we have this 1 minus 0, but since we have this one over here, we can just put it over here, which is then 1 minus 1, which is, yeah, basically 0. Then we have 1 minus 0 here as well, again, sorry. And we just put it like this. We write the 2, we subtract, we get 1, and then we have 1 minus 1, which is 0. Yeah, but as you can see, this method isn't very good, and if we were to implement it in a computer, for example, it would not be very efficient. That is why we have other methods, but I'm going to be explaining those in another video. Yeah, so for this video, that is what I wanted to tell you. So yeah, that's all of it, I think. So yeah.